So moving on to question 4 here, we're dealing with cubic equations and roots of a cubic equation. So it has a transformation that's applied to the roots as well. Now for this question here, we've got this equation and we have the roots alpha, beta and gamma. And without solving the equation, we have to find these roots now that are given. So there's a couple of ways you can actually do this. I think the easiest way personally, in my opinion, is to use a substitution. So the first thing we do with a substitution, you can use whatever letter, but a very common one is W. So we say W is going to be equal. So in this case, because it's alpha plus 1, beta plus 1, gamma plus 1, we're going to let W be equal to x plus 1. But now we rearrange it so it's x equals. So what that means is that x is going to be equal to W minus 1, like that, right? Now what we need to do is substitute this x back into the equation. So what that means, it's going to be W minus 1 cubed, W minus 1 cubed, minus 9 lots of W minus 1 squared, minus 1 squared, plus 2 lots of x, so 2 lots of W minus 1, minus 1, and then finally we add the 1 at the end, plus 1. And now all we need to do is expand all of these. So you're expanding this, these 3 brackets here, you're expanding the 2 brackets here, and then timing it by minus 9. This will be 2W minus 2 plus the 1 at the end. So I'm not going to show all the expansions here because hopefully it's reasonably trivial, expanding 3 brackets and such, but I'll show you what you should get here. So what you should get is W cubed minus 3W squared, minus 3W squared plus 3W minus 1. So we've dealt with the cubic here. Now it's minus 9W squared minus 9W squared plus 18W plus 18W minus 9, and then we have plus 2W minus 2, and then finally a plus 1 at the end, plus 1 at the end. So if we simplify all this now, what this is going to give is that the equation is W cubed minus 12W squared plus 23W minus 11 is equal to 0. And you find the respective integers here of P, Q and R, which is given below here as minus 12, 23 and minus 11. So hopefully that's okay. Quite a nice 5 marks for that question, and there we go.